Hello everyone, welcome to the channel. In this video, we will see the problem on impulse and momentum. The problem states that two particles of masses 10 kg and 20 kg are moving along a straight line towards each other at velocities of 4 meter per second and 1 meter per second respectively. If E, that is coefficient of restitution, is 0.6, determine the velocities of the particles immediately after their collision. Okay, so now we'll let the given data. So mass 1 equal to 10 kg and mass 2 equal to 20 kg. Velocities, that is the initial velocity, that is u1 equal to 4 meter per second, and u2 initial velocity of the second mass, it is 1 meter per second. They are given E equal to 0.6. So we have to find after collision velocity, right? That is v1 and v2. We have to find v1 and v2. Okay, now for this what we can do is we can just draw the first, what is the solution before collision. So before collision we have a straight line, and here we have two mass. One is 10 kg, another one is 20 kg. So for 20 kg I'm just drawing a bigger circle. Okay, so now here mass 1, this is mass 1, m equal to 10 kg and u1 equal to 4 meter per second. So 4 meter per second. Now here what is happening is that this first body is moving in this direction, right? And the second body, for second body we have m2 equal to 20 kg and u2 equal to 1 meter per second. So it is also moving in this direction, right? So before collision, this is the status of the bodies. Now we have to find after collision, right? So immediately after collision. So after collision, so similarly, a straight line, it will be straight line. Because here we have the collision happen, right? So what will be here, the masses will be same, m equal to m1 equal to 10 kg and m2 equal to 20 kg. So here the masses will be remain same, right? So what about the velocities? So what about the velocities? So we have to find v2 and we have to find v1, right? So here they have given two data. One is coefficient of restitution and law of conservation moment. Here we will be using two parameters. One is by law of conservation of momentum, we know that initial velocity equal to final velocity, right? That is initial velocity, so initial momentum equal to final momentum. So initial momentum will have m1 u1, initially is m1 u1 plus m2 u2 equal to m1 v1 plus m2 v2. So here we know the mass, that is 10 kg into u1 is 4 meter per second plus m2 is 20 kg. Now see the direction of the velocity of the second body. So here the direction is from left to right, so we'll take it as a positive, and from right to left we'll take it as a negative, right? So here the velocity of this body 2 will be -1. This will be equal to mass remain the same, 10 into v1 plus 20 into v2. Okay, so we have to do the calculation now. 40 minus 20 equal to 10 v1 plus 20 v2. So it remains 20 equal to 10 v1 plus 20 v2. We can further simplify this. We can have the equation as v1 plus 2 v2 equal to 2. So this is our first equation from the law of conservation of momentum. Now we know that they have given the coefficient of restitution. Coefficient of restitution E equal to 0.6, right? So we know the formula for coefficient of restitution is velocity separation, that is v2 minus v1, separation means after collision, divided by velocity approach. Approach is initial velocity, that is u1 minus u2. Okay, so here we know the E value, that is 0.6. We don't know v2 and v1. It will be remain as it is. So we know the velocity of v1 is 4 meter, and the velocity of u2 is, again, if you see the direction of the u2, it is left to left, so negative. So minus of 1. So here you will have 5, that is v2 minus v1 equal to 0.6 into 5. This gives me, I am going to rearrange the term as well. So minus v1 plus v2 equal to 3. So this is my second equation from the coefficient of restitution. Now what we can do is we can solve the equation, solve equation 1 and 2 to get v1 and v2. So you can put it in the calculator. You can take the equation mode, equation, and we have two unknowns, right? v1, v2. We can take the first one. So the coefficient of v1 is from first equation is 1, and the coefficient of v2 is 2, equal to constant is 2. And from the second equation, the coefficient of v1 is minus 1, equal to 1, equal to 3. So we'll get the value for v1 is equal to minus of 1.33 meter per second, and v2 equal to 5 by 3, that is 1.66 meter per second. Okay, so these are the required velocities immediately after the collision of two bodies. So if you see, v1 is having the negative minus, that means it is moving in the right to left direction, and here the v2 is positive, that is moving from left to right direction. So in the after collision, you can say that v1 is having the negative sign, so it is moving from right to left direction, v1. Okay, it is 1.33, and v2 is moving from left to right direction, that is v2, it is 1.66 meter per second. I hope you understood this problem. If you have any doubt, you can put it in the comment section. Thank you for watching.